The rectangular array or rectangular arrangement of elements in rows and columns is called a matrix. All scalar matrices are example for diagonal matrices, but all diagonal matrices are not example for a scalar matrices. The matrix of order can be denoted as A11, A12, A21 and A22 for 2 rows 2 columns. This is 2 rows 2 columns. Hello dear students, welcome to this session of revision class. I am Mr. Niranjan, Faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, in this session I am going to discuss regarding the very important and easiest chapter, that is matrices. Matrices, then determinant. Now here I am going to discuss only the problems which will appear for the examination. These problems are very important. What are the problems I am going to solve today in this session is very important for the point of examination. If you solve all these problems, definitely you will get good marks in the examination. Now let us start with, now in the revision class we are doing, now let me see what is the weightage for this chapter. So according to this latest syllabus, the exam which you are going to face in the month of April, for that they have modified. The weightage is one 1 mark question and one 2 mark question and one 3 mark question and one 5 marks question. Totally you will get 11 marks from this chapter. So 11 marks from this chapter. So if you read matrices, determinants, LPP, vectors and inverse trigonometric function, definitely you will get a very good marks. Okay, now so the weightage here is 11 marks. Now let me start with the definition. Here I am going to start with the definition and the different types of matrices and the construction of the matrices of 1 mark, 2 marks and 3 marks questions, as well as 4 marks and 5 marks questions. Now let me start with the definition. What is the definition? You are all familiar with the matrices. Now a matrix is nothing but the rectangular arrangement of elements. The rectangular array or rectangular arrangement of elements in rows and columns is called a matrix. The rectangular arrangement of elements in rows and columns is called a matrix. Here the rectangular arrangement, this is an example for a matrix. 1 5 minus 9 2 4 5. This is one matrix. Another matrix 3 2 1 4 0 1 3 minus 3 1. This type of arrangement of elements in a square bracket like this is also a matrix. So the rectangular arrangement of elements in rows and columns is called as a matrix. The horizontal lines are called as the rows. These are called as the rows. The horizontal lines are called as the rows, whereas the vertical lines, these lines are called as the columns of a matrix. Right? The arrangement of elements in rows and columns is also a matrix. Arrangement of elements in rows and columns is called a matrix. So the horizontal lines of the elements are called as the rows and the vertical lines are called as the columns. So this matrix contains how many rows? One row, row number 1 and row number 2. 2 rows. How many columns? Column 1, column 2 and column 3. So here also this contains first row, second row and third row. Whereas this contains first column, second column and third column. So by knowing the number of rows and columns, we can write the order. The order of a matrix is nothing but number of rows into number of column. Order of a matrix is equal to rows into column. The rows into column will give the order of a matrix. Here this is a matrix of order 2 rows and 3 columns. This is a matrix of order 3 rows 3 columns. So for the first matrix, order is 2 into 3. For the second matrix, the order is equal to 3 into 3. Okay, the order. Okay, the order of a matrix is equal to number of rows into number of columns. The order will actually determine the number of elements present in the given matrix. Right. Let us know regarding the order of a matrix. What is the order? Order of a matrix is defined as the number of rows into column. So order of a matrix is always equal to rows into column. The rows into columns will give the order of a matrix. So a matrix having m rows and n column is denoted as m cross n. Now let us consider, for example, a matrix. This is a matrix 2, 3, 4, 2, 1, 5. This matrix has how many rows? one row, first row, then second row and third row. So this has 3 rows and how many columns? 1, 2, 2 columns, first column, second column. So this is a matrix of order 3 rows, 2 columns. So the order of a matrix will determine the number of elements present in that matrix. So this contains 6 elements. Here what is the order? Order is 2 into 2. See, first row, second row, first row, second row, and these are the columns, first column and second column. So 2 rows and 2 columns. Suppose if you want to write a matrix of order A is equal to 2 rows, 3 columns, we are going to write first 2 rows. 1, 2, 1, 2, 3, 4, 2, 1. So this is 2 rows and the number of columns are 3. 2 rows, 3 columns. So in general, if a matrix of order m rows and n column is denoted as, so this is A11, A12, A13, etc. A1n, A21, A22, A23, etc. A2n, A31, A32, A33, etc. A3n. Suppose if m rows, AM1, AM2, AM3, etc. AMN. That means this matrix contains m rows, 1, 2, 3, 4, 5 m rows and the number of columns 1, 2, 3, 4 n columns. So this contains m rows and n columns. So therefore the order of this matrix is m cross n. Now usually for constructing the problems of order 2 rows 2 column, 3 rows 3 column, 2 rows 3 column, 3 rows 2 column, we are using the concept of this. So suppose if you want to construct a matrix of order 3 rows 3 column, we are going to use these 3 elements: A11, A12, A13, A21, A22, A23 and A31, A32 and A33 for 3 rows and 3 column. Suppose if you want to construct a matrix of order 2 rows 2 column with the given condition Aij, so we can use these elements. So that is A11, A12, A21 and A22. So once if you know this concept, then you can construct a matrix of given condition. This is the concept we are going to use to construct a matrix depending upon the given conditions for I and J. So this is regarding a matrix. So in general, a matrix of order m cross n is denoted as this, m into n. That's it, m rows and n column. That is regarding the order of a matrix. Then the types of matrices. Now you might have been studied the different types of matrices. So a row matrix means a matrix having only one row is called a row matrix. A matrix having only one row is called a row matrix. For example, this is a row matrix. And similarly, a column matrix means column, C-O-L-U-M-N. Column matrix means a matrix having only one column is called a column matrix. This is an example for a column matrix. Here the order is 1 row 3 column. Here the order is 3 into 1. So in general, a matrix having one row is called a row matrix. A matrix having only one column is called a column matrix. Now let us come to the square matrix. What is a square matrix? Square matrix means, square means same. The number of rows is equal to number of columns. A matrix in which the number of rows are equal to number of columns is called a square matrix. Usually square matrices of order 2 rows and 2 columns, 2 into 2 and 3 into 3. This is a square matrix of order 3 rows and 3 columns. This is a square matrix. So 3, 2, 1, 0, 1, 2, 3, 2, 1. This is a square matrix of order 3 rows and 3 columns. Okay, this is a square matrix of order 3 rows and 3 columns. Let us consider another example. A is equal to 1, 2, 3, 4. This is a square matrix of order 2 rows and 2 columns. Okay, so these are all examples for square matrices. A square matrix means a matrix in which the number of rows is equal to number of columns is called a square matrix. Okay, now let us come to the next one, diagonal matrix. Diagonal matrix means it's a square matrix, that is number of rows is equal to number of columns. A square matrix A is said to be a diagonal matrix if all the non-diagonal elements are 0. All the elements are 0 except the principal diagonal elements. All the non-diagonal elements are 0. See, 2, 0, 0, 0, 4, 0, 0, 0, 5 is an example for a diagonal matrix. It's a square matrix. How to define a diagonal matrix? It is a square matrix. A square matrix A is said to be a diagonal matrix if all the non-diagonal elements are 0. all the elements are 0 except the principal diagonal elements. 2 0 0 0 4 0 0 0 5 is an example for a 3 rows 3 column matrix. Another matrix, let us consider another example. A is equal to 2 0 0 4. This is also an example for a diagonal matrix. The next definition, scalar matrix. It's a diagonal matrix. First of all, it is a diagonal matrix, means all the non-diagonal elements are zeros. It's a diagonal matrix. A diagonal matrix A is said to be a scalar matrix if the diagonal elements are equal. So, it's a diagonal matrix in which all the diagonal elements are same, equal. That is 5 0 0 5 is an example for a scalar matrix of order 2. 2 rows 2 column. 3 0 0 0 3 0 0 0 3 is an example for a scalar matrix of order 3 rows 3 column. This is 2 rows 2 column. This is 3 rows 3 column. Let us consider another example. So, say for example, another example, x is equal to 1 0 0 0 1 0 0 0 1. This is also an example for a scalar matrix of order 3 rows and 3 columns. So, scalar matrix means it's a diagonal matrix in which all the principal diagonal elements are same. Okay, all scalar matrices are example for diagonal matrices, but all diagonal matrices are not example for a scalar matrices. So, these are all scalar matrices of order 2 rows and 3 columns. This is also a scalar matrix. For this, we have a special name that is called an identity matrix, because if all the elements are 1 1 1 in the principal diagonal, then it is called an identity matrix denoted as I. Okay. Now, let us come to the next type. These are all very important definitions for 1 mark. These are all 1 mark questions. Okay. Now, identity matrix, or it is called as unit matrix. A square matrix in which all the principal diagonal elements are same. If all the principal diagonal elements are equal to 1 and other elements are zeros, then it is called as a identity matrix and denoted as I. Or it is a scalar matrix in which all the diagonal elements are equal to 1. Simple definition. Identity matrix is a scalar matrix in which all the diagonal elements are equal to 1. All the principal diagonal elements are equal to 1. Or a square matrix in which all the principal diagonal elements are equal to 1 and the other elements are zeros. A matrix in which all the principal diagonal elements are equal to 1 and other elements are zeros, and it is denoted as I, capital I. Example for an identity matrix is 1 0 0 1 is an example for 2 rows 2 column identity matrix. 1 0 0 0 1 0 0 0 1 is an example for an identity matrix of order 3 rows and 3 column. Okay. So, an identity matrix is not denoted as capital I. This is also an example for an identity matrix 1 0 0 0 1 0 0 0 1. Okay. Right. Now, all the elements are zeros except the principal diagonal elements, and the principal diagonal elements are equal to 1. Okay, that is called an identity matrix denoted as capital I. Now, next, zero matrix or null matrix. Zero or null matrix means a matrix in which all the elements are zeros is called a zero matrix or a null matrix, and it is denoted as 0. So, a matrix in which all the elements are zeros is called a zero matrix or a null matrix, and it is denoted as 0. So, these are all example for null matrices of order. This is 1 into 1, this is 2 into 2, and this is 2 rows and 3 column. Another matrix, say for example 0 is equal to 0 0 0 0 0 0. This is a null matrix of order 3 rows and 3 column. Okay. These are all example for a null matrices. So, a matrix in which all the elements are zeros is called a null matrix, and it is denoted as 0. Okay. Hope you followed. So, these are few types of matrices and the definition. So, definitely you will get one question from this for 1 mark. Okay. So, 1 mark questions are very, very important for you in the examination, because to get 100 out of 100 sentence, to get sentence, 1 mark questions are very important. You have to concentrate more on 1 marker question. So, usually you may get 1 mark questions from the definition. And one more additional question you may expect from this is the construction, like this. Suppose, now let us come to your 1 mark problems. Yeah, if a matrix has 8 elements, what are the possible orders it can have? Suppose if a matrix has 8 elements, then what are the possible orders that we can construct from this 8? As I told now itself, if a matrix contains n order, means then it contains m into n number of elements. Suppose if a matrix contains 2 into 3 order, means then it contains 6 number of elements. So here what is given? A matrix contains 8 elements. The possible orders are, we can write 1 into 8, 1 into 8 is 8, 2 into 4, 2 4s are 8, then we can't take 3, again 4, 4 into 2 is 8, again 8 into 1 is 8. So these are the 4 possibilities orders we can write. So 4 possible orders are 1 comma 8, 2 comma 4, 4 comma 2 and 8 comma 1. These are 4 possible orders that we can construct for a matrix having 8 elements. So if a matrix has 8 elements, then all the possible orders that we can have is 1 into 8, 8 into 1, 2 into 4 and 4 into 2. That's it. Okay. Now let us come to a similar problem. Suppose if a matrix has 24 elements, so a matrix having 24 elements, then what are the possible orders? First is 1 into 24. Next is 2 into 12. 12 2s are 24. Again from 3, is it possible? 3 into 8. 8 3s are 24. Then from 4, 4 6 are. Then 5 not possible. Again from reverse 6. 6 4s are 24. Again we will come to 8. 8 into 3. 8 3s are 24. Again 12 into 2. 12 2s are 24. Again 24 into 1. So these are all the possible orders. So 1 into 24, 2 into 12, 3 into 18, 4 into 6, 6 into 4, 8 into 3, again 12 into 2 and 24 into 2. 24 into 1, sorry. So the possible orders are 1, 2, 3, 4, 5, 6, 7 and 8. 8 possible orders we can write for a matrix having how many elements? 24 elements. Okay, right. Now let us come to the next problem. What is the next? Same. Write all the possible orders if a matrix has 13 elements. Since it's a odd number, so for 13 elements we can write 1 into 13 and 13 into 1. Only 2 possibilities. So these are the 2 possible orders we can write. 1 into 13 and 13 into 1 for the matrix. So you may expect this type of question for 1 mark also. Now let us come to the next. Now let us come to the next type of problem. The next type of problem, again this is also for 1 mark. Construction of matrices. Construct a 2 cross 2 matrix where A is equal to Aij and where Aij is defined by I by j. Now as I told in the beginning itself, while writing the order, the matrix of order can be denoted as A11, A12, A21 and A22 for 2 rows 2 column. This is 2 rows 2 column. So here what is given? The value of A is equal to Aij is given by I by j. I by j is nothing but I divided by j. Here A11 1 by 1, 1 by 2, 2 by 1 and 2 by 2. That's all. This is equal to 1 by 1 is 1, 1 by 2, 2 by 1 is 2, 2 by 2 is equal to 1. This is a matrix of order 2 rows 2 column. That's it. Just divide. A11 1 by 1, 1 by 2, 2 by 1, 2 by 2, 1, 1 by 2, 2 comma 1. This is the matrix of order 2 rows 2 column defined by I by j. Now let us come to the second problem. What is the second problem? 2 rows 3 column given by Aij is equal to 2i minus j. Now let us write first 2 rows 3 column. 2 rows A11, A12, 2, A13, again A21, A22, A23. So this is 2 rows and 3 column. 2 rows 3 column. Write down the elements. What are the elements we have? Therefore A is equal to, straight away we can write 2i minus j. So for a11, 2 into 1 minus 1, and again 2 into 1 minus 2, again 2 into 1 minus 3. a11, a12, a13. Similarly, you can write for the second row. What is the first element? 2 into 2. 2 into 2 minus 1. Again 2 into 2. 2 into 2 minus 2. Again 2 into 2 minus 3. 2 into 2 minus 3. So this is equal to, see here, 2 ones are 2 minus 1 is 1. 2 ones are 2 minus 2 is 0. 2 ones are 2 minus 3 is minus 1. Again 2 to the 4 minus 1 is 3, 2 to the 4 minus 2 is 2, 2 to the 4 minus 3, 4 minus 3 is 1. This is a matrix of order 2 rows 3 columns. That's it. Okay. See here, 2 into 1, 2 into 1 minus 1, 2 into 1 is 2 minus 1 is 1, 2 into 1 is 2 minus 2 is 0, again 2 into 1 minus 3, 2 into 1 minus 3 is 2 minus 3, 2 minus 3 is minus 1, again for the second row, 2 into 2, 4 minus 1, 4 minus 1 is 3, again 2 into 2, 4 minus 2, 4 minus 2 is 2, again 2 into 2, 4 minus 3 is equal to 1. So these are the elements, that's it. Okay. Now let us come to the next problem. Now same, construct a 2 cross 2 matrix given by aij is equal to I minus j whole square. So what is A? Again a11, a12, a21 and a22. What are the elements given? A is equal to, what is the condition? Aij is equal to I minus j whole the square. Now let us write the elements. A is equal to a11, 1 minus 1 whole square, 1 minus 2 whole square, again 2 minus 1 whole square, 2 minus 2 whole square. That's it. So 1 minus 1 is 0 square is 0, 1 minus 2 is minus 1 square is plus 1, 2 minus 1 is 1, this is 0. An identity matrix, you will get 1, sorry not identity, you will get 0, 1 and 1, 0, 0, 1 and 1, 0 you will get. Okay. So here A is equal to I minus j whole square, 1 minus 1 whole square, 1 minus 2 whole square, 2 minus 1 whole square, 2 minus 2 whole square, 0, 1, 1, 0. Right. Now next come to the next problem. Next problem is a 3 rows 3 column. You may expect this for 2 marks. So aij is given by 2i minus j, 2i minus j. Now here A is nothing but 3 rows 3 column, a11, a12, a13, a21, a22, a23, a31, a32 and a33. Now this can be written as A is equal to the matrix 2i minus j, 2 into 1, 2 minus 1, again 2 into 1 is 2 minus 2, again 2 into 1 is 2 minus 3. This is the first row. And the second row, for the second row just multiply by 2. 2 into 2 is 4 minus 1, again 2 into 2 is 4 minus 2, 4 minus 2, again 2 into 2 is 4 minus 3. Next, for the third row, multiply by 3. 3 into 2 is 6 minus 1, 6 minus 2 and 6 minus 3. That's it. So, here 3 to the 6 minus 1, 3 to the 6 minus 2, 3 to the 6 minus 3. So, if you simplify, what is the answer you are going to get for this? 2 minus 1 is 1, 2 minus 2 is 0, 2 minus 3 is minus 1, again 4 minus 1 is 3, 4 minus 2 is 2, 4 minus 3 is 1, 6 minus 1 is 5, 6 minus 2 is 4, 6 minus 3 is 3. This is a 3 rows 3 column matrix. The condition is 2i minus j. That's it. Okay. Hope you followed this. So like this we are going to construct a matrix of any order depending upon the given condition. Okay. Now let's come to the 2 marks problem. Now let us come to this equality of matrices. So from equality of matrices, 2 matrices are said to be equal if and only if they are of same order and the corresponding elements are same. 2 matrices are said to be equal. Matrix A and B are said to be equal. A is equal to B if and only if they are of same order and the corresponding elements are same. Now based on that, let me discuss this problem. Find the value of A, B, C, D from the following equation. So you may expect this type of questions also. Now by equality of matrices, by equality of matrices, 2a plus b is equal to 4a plus b, and a minus 2b is equal to minus 3, and 5c minus d is equal to 11, and 4c plus 3d is equal to 24. See, these are the four equations. Now, so you can solve this. So from these two equations, transfer this. 4a plus b minus 2a minus b is equal to 0. Plus b minus b gets cancelled. 4a minus 2a is equal to 2a. 2a is equal to 0. Therefore, a is equal to 0 by 2 is 0. A is equal to 0. Now, substitute here. So, here a minus becomes plus 3 is equal to 2b. Now, put a is equal to 0. If you put a is equal to 0, what you will get? 0 plus 3 is equal to 2b. Therefore, b is equal to 3 by 2. Now, substitute from these two equations. What is the value we are going to get here? So, from this, 4c plus 3d is equal to 24. 5c minus d is equal to 11. Now, solving these two, let us represent this as equation number 1 and this as equation number 2. Solving these two equations from 1 and 2. From 1 and 2, 5c minus d, this is 4c plus 3d is equal to 24. Now, let us multiply this with 3. If you multiply, 5 3s are 15c minus 3d is equal to 33. This is same. 4c plus 3d is equal to 24. Add. If you add, what you will get? Plus 3d minus 3d gets cancelled. 15 plus 4 is 19c is equal to add. So, 3 plus 4 is 7. 5 plus 2 is 27. So, therefore, c is equal to 57 by 19. That's equal to 3. C is equal to 3. Now, from this equation, 5c minus d is equal to 11. How to find d? 5c minus 11 is equal to d. What is c? 3. 5 into 3 minus 11 is equal to d. So, 5 3s are 15 minus 11 is equal to 4. D is equal to 4. That's it. So, here this is d is equal to 15 minus 11 is 4. So, therefore, the values of a 0, b, what is b? 3 by 2, c, what is c? 3, and d is equal to 4. These are the values of a, b, c, d. So, usually you may get this type of problems for 2 marks. Okay. Now, let us come to the next problem. Now, find the values of x, y and z from the equation. This is very simple problem and important type problem. So, very simple, just by equality of matrices, we can write the value of y is 4, y is equal to 4, and the value of x is equal to 1, this is x, and the value of z is equal to 3, z is equal to 3, that's it. Therefore, x is equal to 1, y is equal to 4, and z is equal to 3. These are the values. If you do this much, you will get 2 marks. Very simple. So, by equality, y is equal to 4, z is equal to 3, x is equal to 1. That's it. Now, let us come to the next equation, next problem. Find x, y and z from the following equation. This is also a very important type of problem. What is the problem given? X plus y plus z by equality. We can write by equality of matrices. Alright, x plus y plus z is equal to 9. Let us represent this as equation number 1. X plus z is equal to 5, equation number 2. Y plus z is equal to 7, equation number 3. Now, let us solve from 1 and 2. From 1 and 2. What is 1? X plus y plus z. X plus y plus z is equal to 9. What is 2? X plus z is equal to 2. So, x plus z, this is x plus z. So x plus z plus y is equal to 9. What is x plus z? 5 plus y is equal to 9. Y is equal to 9 minus 5 is 4. So y is equal to 4 is one value. Now substitute here. Now from this, from 3, z is equal to 7 minus y. What is y? Y is equal to 4. 7 minus 4 is equal to 3. Z is equal to 3. Now from this, x plus z is equal to 5. X is equal to 5 minus z. 5 minus 3 is equal to 2. X is equal to 2. So therefore, x is equal to 2, y is equal to 4 and z is equal to 3. See, if you add 2 plus 4 plus 3, x plus y plus z is 9. 4 plus 3, 7, 7 plus 2, 8, 9. You will get the answer. That's it. Very simple. So, x plus y plus z is 9, x plus z is 5 and y plus z is equal to 7. If you want, you can straight away substitute y plus z is 7 here. Y plus z is 7. So, x is equal to 9 minus 7 is 2. X is equal to 2. Again, if you substitute z, x value, z is equal to 5 minus x. Z is equal to 5 minus x is 3 you will get. And y is equal to 7 minus z, you will get it as 4. So, therefore, any method you can follow, substitute the value of y and z or x and z, nothing, it won't change us anything. So, x plus z is 5, y is equal to 9 minus 5 is 4 and y plus z is 7, z is equal to 7 minus y, 7 minus 4 is 3. Substitute here, x is equal to 5 minus z, that you will get x. So, these are the required answers. Okay, right, followed, hope you followed. Let's come to the next problem. What is given? If x plus y 3, x minus y minus 6 is equal to 2, 3, 4 minus 6, find the values of x and y. This is also a very important type of question for 2 marks. Again, by equality of matrices, x plus y is equal to 2, 3, 3 equal and x minus y is equal to 4, minus 6 are equal. Now let us solving these two. Solving x plus y is equal to 2 and x minus y is equal to 4. Let us call it as 1 and 2. Solving 1 and 2. This is equation number 1 and this is equation number 2. Add. If you add, minus y plus y gets cancelled. 2x is equal to 6. X is equal to 6 by 2 is 3. X is equal to 3. Substitute this value in any one of the equation from 1. What is 1? X plus y is equal to 2. Y is equal to 2 minus x. That is 2 minus 3 is minus 1. Y is equal to minus 1. Therefore, x is equal to 3. Y is equal to minus 1. So, these are the answers. See, if you want, you can substitute. If you put x is equal to 3 and y is equal to 1, 3 minus 1 is 2. Or if you put x is equal to 3 and y is equal to minus 1, 3 minus of minus is plus, 3 plus 1 is 4. You will get. That's it. Okay. Just equate it and solve the simultaneous equations. Now, let us come to the next problem. The number of possible matrices of order 3 cross 3 with entry 0 or 1 is, see here there are two entries. The number of possible matrices of order 3 cross 3. Okay. So, here given 3 cross 3. So, in 3 cross 3 matrix there are 9 elements. Since in 3 cross 3 matrix, how many elements are there? 9 elements. Okay. And what are the elements given? 0 and 1. There are 2 elements they have given. So, with these 2 elements, so each element can be filled in 2 ways. Each element can be filled in 2 ways as 2 into 2 into 2. How many times? 9 times. So, therefore, this can be written as 2 to the power of 9 is equal to 512. So, these are the possible ways. The number of all possible matrices of order 3 cross 3 with entries 0 and 1 is 512. This is very important problem. Okay. Suppose if it is of order 2 rows 2 column, 0 with 2 elements, 2 and 2. So we can write the number of, since in 2 rows, 2 column, we will have 4 elements. Each element can be filled in 2 ways. So that is 2 into 2 into 2 into 2, 4 times. So that is nothing but 2 to the power of 4. So that is 2 to the 4, 4 to the 8 to the 16. So a 2 rows 2 column matrix can be filled in 16 ways, whereas a 3 rows 3 column can be possible, number of all possible matrices of order 3 cross 3 with elements 0 and 1 is 512. Number of all possible matrices of order 2 cross 2 with 0 and 1 is 16. That's it. These two problems are very important. Let us come to the next. Suppose if A is equal to 2, 4, 3, 2, B is equal to 1, 3, minus 2 and 5. Now these are the operations on matrices. Now you might have been studied operations like addition, subtraction, scalar multiplication, matrix multiplication. Now today I am going to discuss regarding addition, subtraction and scalar multiplication. In the next session we will discuss regarding the matrix multiplication. Now you may expect one question for 2 marks or 3 marks from this concept also. Now let me straight away go to the problem. What is the problem? If A is equal to 2, 4, 3, 2 and B is equal to 1, 3, minus 2, 5, find A plus B. Let us come to the first one, A plus B. This is called addition. Write down the value of A, 2, 4, 3, 2 plus B. What is B? 1, 3, minus 2 and 5. Just add the corresponding elements. 2 plus 1, 4 plus 3, then 3 minus 2 and 2 plus 5. This is equal to 2 plus 1 is 3, 4 plus 3 is 7, 3 minus 2 is 1, 2 plus 5 is 7. Again this is a 2 rows 2 column matrix. So this is your A plus B. See, A 2, 4, 3, 2, B 1, 3, minus 2, 5, add 2 plus 1 is 3, 4 plus 3 is 7, 3 minus 2 is 1, 2 plus 5 is 7. Right. Now let us come to the second part. Second one is A minus B. What is A? A is equal to 2, 4, 3, 2 minus B 1, 3, minus 2 and 5. Subtract this. 2 minus 1, 4 minus 3, again 3, minus into minus it is plus, 2 minus 5. So what is this equal to? 2 minus 1 is 1, 4 minus 3 is 1, 3 plus 2 is 5, 2 minus 5 is minus 3. This is A minus B and this is also of order 2 rows 2 columns. So if you do this much you will definitely get 2 or 3 marks. Very simple. Okay, addition and subtraction, sum or difference of two matrices. Okay, now let us take one more problem based on matrix addition, subtraction and scalar multiplication. Now let us come to this problem, very important problem. If A is equal to 2, 4, 3, 2, B 1, 3, minus 5, minus 2, 5 and C is equal to minus 2, 5, 3 and 4, find one by one. Let me come to the first one, 2A plus B. 2 into what is A? 2, 4, 3, 2 plus B 1, 3, minus 2 and 5. Now multiply this each and every element by 2. That is called scalar multiplication. We have to multiply all the elements by 2. 2 into 2 is 4, 2 4s are 8, 2 3s are 6, 2 2s are 4 plus 1, 3, minus 2 and 5. Now add, corresponding element must be added. 4 plus 1 is 5, 8 plus 3 is 11, 6 minus 2 is 4, 5 plus 4 is 9. This is the first answer. This is 2A plus B. Now come to the second one. What is the second one? A minus 2B. Write down A. What is A? 2, 4, 3, 2 minus 2 into B. 1, 3, minus 2 and 5. This is 2, 4, 3, 2 minus, multiply by 2. 2 1s are 2, 2 3s are 6, 2 2s are 4, 2 5s are 10. Subtract this. This is 2 minus 2 is 0, 4 minus 6 is minus 2, 3 minus into minus plus, 3 plus 4 is 7, 2 minus 10 is minus 8. That's it. Okay. Next one. What is the next? 2A minus C. I'll go here. Third one. 2A minus C. 2 into A. What are A elements? 2, 4, 3, 2. 2, 4, 3, 2. Let me check. 2, 4, 3, 2. Minus C. What is C? This is C. Minus 2, 5. Minus 2, 5, 3, 4. Now simplify this. Just multiply with 2 first. 2 2s are 4, 2 4s are 8, 2 3s are 6, 2 2s are 4, minus 2, 5, 3 and 4. Subtract this. See here, 4 minus into minus plus 2, 4 plus 2, 8 minus 5, 6 minus 3, 4 minus 4. Add this. 4 plus 2, 6, 8 minus 5, 3, 6 minus 3, 3, 4 minus 4, 0. That's all. 6330 is the third answer, right? Now let us come to the last fourth one. What is the fourth? We have 2c minus a. 2c minus a. 2 into c is minus 2, 5, 3, 4 minus a. What is a? A is 2, 4, 3, 2. Subtract this. Just that's it. Multiply by 2, minus 4, 10, 6, 8, minus 2, 4, 3, 2. Subtract this. This is equal to, see, minus 4 minus 2 is minus 6, 10 minus 4 is 6, 6 minus 3 is 3, 8 minus 2 is 6. This is the required answer. Minus 6, 6, 3, 6 is the required answer. That's it. Okay. Now, let us come to the next problem. Now, compute the following matrices. What is the given? One matrix, another matrix. This is 2 rows, 2 columns. This also 2 rows, 2 columns. So, this can be written as the given matrix, given equation becomes cos square, addition, just cos square x plus sin square x. Again, sin square x plus cos square x. Sin square x plus cos square x. Again, sin square x plus cos square x. Cos square x plus sin square x. So, you know this is an identity. Sin square theta plus cos square theta is 1. Cos square theta plus sin square theta is also equal to 1. 1, 1, 1, 1 is the required answer. Cos square plus sin square 1. Sin square plus cos square is 1. Sin square plus cos square is 1. Cos square plus sin square is 1. That's it. Okay. Sin square theta plus cos square theta is equal to 1. Right. Now, let us come to the next one. If x 2, 3 plus y minus 1, 1 is equal to 10, 5. Find the value of x. Now, let us simplify this. Multiply by x, 2x, 3x plus multiply by y minus y plus y is equal to 10, 5. Now, add these two matrices. 2x plus into y is minus y. 3x plus y is equal to 10 and 5. Now, by equality of matrices, by equality, see this is 2 rows, 1 column, this also 2 rows, 1 column, you can equate it. 2x minus y is equal to 10, equation number 1. 3x plus y is equal to 5, equation number 2. Now, 2x minus y is 10, 3x plus y is equal to 5. Solving 1 and 2. If we solve 1 and 2, what are the values we have? 2x minus y is equal to 10. Another one is 3x plus y is equal to 5. Now, let us add this. If we add, minus y plus y gets cancelled. 5x is equal to 15. X is equal to 15 by 5 is equal to 3. X is equal to 3. Now, from any one of the equation, let us take the first equation. From 1, 2x minus y is equal to 10. Just transfer this, that's all. So, 2x minus 10 is equal to y. 2 into x is 3 minus 10 is y. So, 2 3s are 6 minus 10 is minus 4. So, therefore, y is equal to minus 4. So, the values are, therefore, x is equal to, what is x? 3 and y is equal to minus 4. So, if you want, you can substitute here. 3s are 9 minus 4. 9 minus 4 is 5. You will get. That's it. Okay. So, these are few problems based on addition, subtraction and scalar multiplication and the definition. Definitely you will get 1 or 2 questions from this concept. So, whatever the questions I am going to solve in the revision class, you just practice, practice, practice. Definitely you will get the same question for your examination also. Okay. So, hope you followed this. So, that's all regarding today's session. Let us meet with the different concept. In the next class, I am going to take the 3-marker question and 5-marker question based on matrix multiplication. Thank you very much.